Ladies and gentlemen, welcome to Programming League National 2025 Workshop 2. I'm Jay Sharma and I'll be your MC for today. On behalf of the organizing committee, we thank you for your presence today. We sincerely thank everyone who participated in Workshop 1 last week, and for you who joined the last workshop, welcome back. Without further ado, let's start with the workshop today with the topic of Intro to Dynamic Programming. For today's workshop, we are blessed to be able to invite Mr. Sam Wei Hong, who is a data science graduate of University Malaya. He was in top 2000 Meta Hacker Cup and won champion for Programming League National Open category in both 2024 and 2023. He was also the champion for Programming League National 2022 closed category and won first runner-up in Code Action 2024 Open category. He has won in Code Action 2023, a national competitive programming competition. Last year, he was also the speaker for the Programming League National 2024 workshop. With this exceptional knowledge, he will guide us through today's topic. Mr. Sam Wei Hong, I will now leave the stage to you.
Yeah, hi everyone. So, so hello to everyone. My name is Sam Wei Hong. So I'm the speaker for the workshop today. Yeah. So, like what the MC said just now, I'm the speaker for the last year for the workshop 1, which is the introduction to competitive programming. So this year, I take a step forward. Before this is CP. Now I move from C to D. So today we will talk about the dynamic programming, which is a very important skill in CP, right? So let's go on. So in a normal workshop, usually when we are doing the introduction to DP, right? The normal workshop, they will tell you the meaning of DP right in the beginning of the workshop. But today I want to do it differently. I won't tell you what is DP for now, but in the middle of the workshop, you will suddenly realize that what you are learning through is actually DP. So I promise this workshop will be a world-class workshop, even higher quality than last year. So stay tuned to the end to find out whether what I claim is true or not. All right. So as you know, before I started this workshop, I actually asked the PLN committee to help me to share the 3 contest problems to the participants. So this because I saw from the last year, last session, there are a lot of people that like to do the hands-on version. So I share the problem beforehand so that you can have a try on it. So I can see the results. Very beautiful the result. Let's see. We have 6 people participating in the contest problem. So today we will do a problems-oriented workshop to go through each of the problem to learn how you can apply dynamic programming knowledge into each of the problem, right? So the first problem is a challenge to all of you, is that can you do the multiplication without using the asterisk symbol? During maybe your first class of programming, your instructor may ask you to do the multiplication using the times. But the challenge is, without using it, how are you able to do the multiplication efficiently? And I'm afraid that because of PLN, all the contestants are too powerful, so I need to add 3 more challenges to make it harder. Like don't use the divide symbol, not using for loops, and use the slowest language to increase your challenge, right? So when you heard about not using loops, then how are we going to perform the looping? Like in a normal programming, we want to print thing for a fixed number of times, you use the for loop, right? But if I ban the for loop, what should we do to do the looping? So recursion comes to the rescue, where just by calling the function, you are able to perform looping. So this is a new perspective to the programming you learned before. It's an elegant technique that the function can call itself inside the definition. So you might feel curious that I haven't defined the function, but I can call the function inside it. So how is it possible? So let's try. I also open my VS Code. See, this is the exact same code. So I just give some random number. Since now is 8 and 10, I just put 8 and 10. So hopefully by using this code, since multiply xy, right, is equal to y and x. So hopefully by running this code, you can see the output as 80. Okay. What's going on? You see, the output, we have multiplied 8 and 10, then 10 and 8. And then we got an error in the console. Why is this happening? You see, the logic just now is absolutely correct, but it's useless. Why? Because when I say to multiply 5 and 4, then the program will run, since it's just swapping the number, right? So you calculate 4 multiply 4 and 5. Then how to do this? You also swap the number again. Multiply 5, 4, 4, 5. So until the stack overflow, then we also haven't find the answer. So this is known as the infinite recursion. So basically this, the logic is correct, but it's not useful in finding the answer. So that's why the program crashed. So in today's workshop, let's see how we can fix this problem. So to make this more friendly to the beginners, we create a real world scenario. It's like I'm asking my friend. This is not a real world conversation. So I asked my friend, where is the car? Then he said that it's beside the tree. Then of course I don't know where is the tree. Then I asked him again. Then he said it's beside the car. So this conversation, right, will go through forever if I haven't go to stop the conversation. So what is the scenario that I want? Is this? You see, even though it's the same question, he says that the answer is beside the tree. But when I ask where is the tree, he give a new answer, a new information. He says that it's beside the statue. Then eventually we can reach to a final answer. So this is the difference compared to the scenario just now. So let's see how we can apply the similar logic in the programming. So as learn from the primary school, that multiplication is just addition repeated for multiple times, at least for 0 and positive numbers. Basically, we are saying that 5 times 4 is 4 added 5 times. So if you don't know how to do multiplication, but you know how to do addition, you can do 4 plus 4 plus 4 plus 4 plus 4, and you get the answer. But the thing is, back in my days in the kindergarten, I didn't know how to add 2 numbers. Now to stuff 5 numbers, how to calculate that? So let's take it slowly, one by one. Add 1 number at a time. So you see, 4 added 5 times is 4 plus 4 added 4 times. Very logical, right? And then we can go on. How to do the 4 times? Add a 4 and the 4 added 3 times. We can go on forever, not forever, until we reach the final destination. See? Okay, so here we reach the final case that 4 added 0 time. So for something that is done 0 time, right? What is the answer? 0. See? 4 added 0 time is 0. This is a very obvious answer, right? But with this answer, we are able to go up, bring that answer forward to solve our original problem. So you see, we have 4 added 0 time, right? Can substitute back. So 4 plus 0 equal to 4. Then I know the answer to the previous problem that I initially don't know how to solve. So I substitute back. 4 plus 4 equal to 8. The answer is 8. So 4 plus 8 equal to 12. 4 plus 12 equal to 16. And then I bring it back. I get 4 plus 16 equal to 20. You see, I find the answer. You might feel this is stupid. Why we need to do this one by one? But this is actually what we are going to do in our programming. Since we learned that x times y is the same as saying add y and x minus 1 times y. Because you know what? Every time we do an add, we reduce one number. So you can see at the right side, I have an illustration. Multiply 5, 4 equal to 4 plus multiply 4, 4. So you can see the number keeps going down until we reach the base case, where we have a finite answer. Okay, so let's see. You might feel like, hey, this is the same thing. You see, I'm calling a function inside itself. So this is very different from the, the ordinary programming you did before. You might even ask that whether this program can compile or not. So let's see. See, the answer came out 80. This is not the one I typed just now. I can change any number, maybe 12 times 12. See, 144. Very, very magical, right? Right? We only define one add, but somehow it is able to add more than one numbers. So this is a brand new perspective that I want to convey to you today. Okay, that you cannot learn in the normal workshop. So how does this work? It's actually the same thing I said just now. You see, every time we only do one step, plus the y, and then run the same function, add the number for x minus 1 times. Why x minus 1? Because I already did one time, right? Until we reach the base case where x is equal to 0. That is the time where we know the answer must be 0, because any number times 0 is 0. Somehow by just doing these 3 lines only, we're able to do multiplication. So I'm not going to go through the implementation logic, just to start from a higher level view. So what is the rule of thumbs of doing the recursion? You must make sure the base case exists. So what is the difference compared to the the yx just now? Is that this one we have a base case. Let's compare. Just now there is no something like if and return a definite answer. Like this one, I have an answer 0. That one, no answer, right? We keep going through the multiply, so it never ends. But this one, we have a finite answer, and with that answer, we can go back to the previous step and solve the problem one by one. So this is the main difference. And not only that, you need to make sure that the recursive calls converge to the base cases. So you might not sure what this means yet, but later I'll show you. Essentially, we are reducing problems to the ones we are able to solve. Like I don't know how to solve for 1 times 4, 2 times 4, but I know that anything times with 0 is 0. By just knowing this information, we are able to solve all problems for multiplication. Then you might ask, why you need to set the base case to be 0? Can we set to 10? Let's try. Why if we set to 10? I run this code. Do you think it will run? Put yes if you think it will run in the chat. Let's see how many. If you think it's no, then you put no lah. Let's see how many of you have an answer. No one. No. Yeah, let's try. I press enter. Okay, I remove this first, and I press enter. Hey, we got 144. Why does this work? Because the base case is still valid. Any number with times with 10 is basically adding a 0 after it, right? For example, 12 times 10 is just 12 with a 0 after it, so 112, 120. So this works. But if I change the number, so I set to maybe 1 lah. 1 times 12 is 12, right? Yeah, run the code. Hey, got error. Yeah. Let's see. So the base case is not necessarily to be 0, but there is an advantage for it to be 0. It's because that, still remember what I said just now, you need to make sure the recurrence relation will converge to the base case. Since I'm doing -1, right? Before this is 12 and 12. So 12 minus 1, we get 11. 11 minus 1, we get 10. So we will reach the base case. But just now, what did I do just now is I say to be 1. So 1 minus 1, you get 0. 0 minus 1, -1, -12. So in Python, because you don't have overflow, right? So eventually you never reach x equal to 10. So this is what I mean for make sure your recurrence relation will converge to a base case, because it's the point where you get the answer and you can solve the previous problem. So for just now, we answer yes and no, both correct lah, but in different cases, depends on the input, right? So so we got the original code. So if we submit this, we got a runtime error. But why? It's because that we have a similar issue. You see that the numbers, right, to be multiplied is actually can be at less than -10 to the power of 9, which is a negative number. So it's the same issue just now. Just now it's because I set to 10, right? So numbers that is less than 10, if you keep minus it, you never reach 10. This one is the same. If I start with maybe -1, then you -1, right? -2, -3, -4. You never reach x equal to 0 because the number keeps going down. So this is another example of why I say we need to make sure, like this one, right? Even though the base case is valid, but you need to make sure you are able to reach the base case. These are the two keys to create a good recursion program. So how to fix this? So I give you a challenge how to fix this. Maybe you can try answer the problem in the chat. In the meantime, let's tell a joke. So one day, a mathematician decides he wants to be a firefighter, maybe because he has a higher salary. So he quits the job and applies to be a firefighter. But the firefighter chief doesn't think that he's qualified, so he gives him a test. So he takes him to the airline and sets the dumpster on fire. Then he asks the mathematician, what should you do when you see a fire? And the mathematician has a potential to become a firefighter. So he just use the water to push out the fire. Then the chief asks him again, now that the fire is out, what do you do? Because mathematics, right, is always about reducing the problem into a problem with the known solution. So if I put on the fire, it will reduce the problem just now. You see? So it's not just a joke. It's actually very useful in our recursion program. See? Since we know that for positive numbers, we know how to solve the. For positive numbers, the relation just now is valid. Then we just turn the negative number into a positive using the negative. See, for example, I put -5 and 10. You should expect the answer to be -50. But it doesn't, because we can never reach the base case. So what should we do? What is here? I do this. If x is less than 10, then I put a negative before the x, then what will it become? 5, right? So it will become a positive number again. And we know that this program is valid for positive numbers. So you see, just by adding this one line, we somehow able to solve negative numbers multiplication by turning it into positive. So that's just a joke. Actually, you can learn some moral of the story from the joke. This is to convert the problem into a known solution, like this one. So why does it work? Because -5, you put a negative in front, it still work. You want to put it in front of the 4, it also work. For example, this one, negative, right? It's same as -x times -y. So you run it again. See, still -50. I can remove it. What's going on? I need to save it. See, -50. So that's why I say it's a new perspective problem. It's not about how to I see some of the people, they might do, if x is less than negative, then times the final result with negative after it. But in recursion thinking way, you need to think about how to reduce the problem to the one you are able to solve. So that's why we say that this is a more declarative code. So just by reading it, you know that it's returning a statement only, not like instructing what you should do times with -1 at the end. Okay, so if I submit this code, will it pass the challenge? Also no. Why? But we are able to pass from test 5 to test 7. At least we make some progress. All right. But why is the error this time? It's because that they are very huge numbers. The program will exceed the recursion limit. So there is a limit in Python on how many numbers of times you can run the recursion. If I put a large number, and run again. See, even though the program is correct, but there is a hard limit on the number of times you can run recursion in a program. So this in some language is the function call stack. This one is implementation details, not important. But even though we can run, for example, the recursion is an issue, right? Then just remove the recursion. Let's replace it with a for loop. So this is the same thing just now. Just now I'm doing it recursively, but this time I do it iteratively, which is I start from 0 for every number from 1 to x, I add y to it. So it's the same thing. Even if I do so, I submit the program. What did I get? Time limit exceeded on test 7. Because I purposely set a huge number on that test case to make people feel. So because you can think for example, 100 lah. So for you, if I want you to add 5 for 100 times, so 5 plus 5, 10, 10 plus 5, 15, 20, you need to do it for a very long time, right? Same for the computer. I know computer can do it very fast, but when the numbers go up until 10 to the power of 9, computer also face some challenge, unless you know supercomputer or something. So how can we fix this? It's like if you go from 100, you know, go down slowly. Can we have a faster way to make it more efficient? There is. This method, you know, is known as a divide and conquer. So divide, right? Let's divide by 2. So you can see this, the exact thing just now is 4 added 9 times. I added 4, and I need to do it for another 8 times. But this time, instead of changing it to 7 times, let's do a small improvement. I make it into 4 added 4 times plus 4 added 4 times. It's the same thing, right? It's like I do it 4 times, then I do another 4 times. So in total, it should be 8. I can do it for another time. 4 added 4 times is added 2 times for twice. Same thing for 2 times. You see, I just divide by 2. And then 4 added 1 time, because you cannot divide 1 by 2, right? Evenly. So I use the same equation just now. But right now, we reach the base case where the number is 0. So I replace it with 0. Now I know the answer is 4. I can substitute back. But notice this time, I not only substitute it for once, because there are 2 variables there that can be substituted, right? So I substitute it twice. It's equal to 4 plus 4 equal to 8. And then I can do it again. You see? So 4 added 4 times is 8 plus 8 equal to 16. I can do it another time. 16 plus 16 equal to 32. 4 plus 32 equal to 36. Somehow we don't need to do, 9 additions, but we can get the same answer. It's the same thing for 100. For 100, you divide by 2, 50. 50, it becomes 25. You can see that the numbers go down faster compared to, 199, 98. Very efficient by dividing by 2. This is very powerful. So how can we run this? Using the way of recursion, we don't need to know how the program run. We just type the code. So if the x is even, we can apply the optimization formula, which is, as you can see just now, is basically, for example, 8 times you divide by 2. So the number that is in the recursion function is 4. So 8 divided by 2 is 4. Then you do it plus another time. So see, here is exactly the same thing. So this is the elegant style of writing recursion code. You just describe it. You don't know that, how will we divide by 2? How does it add? You don't need to care about this. So this is more elegant than an iterative, but it comes with a cost, which we'll talk about later. So if x is even, we apply the optimization just now. If it is odd, then we do the formula just now, which is the one before we do the optimization. So hopefully this will be much faster, right? So let's try to do this. Here's the code. So if I run this, you can see, hey, no output. Why is that? My output, no output. Why is that? If I submit this code, we will still getting time limit exceeded. Is division by 2 still too slow? Is the question another question I want to ask. What do you think? Is it because that, the logic is wrong, or there is something in my implementation that is wrong? Can you guess the reason? Chat. Like it seems useful, right? Like we just divide by 2, then we substitute back. But somehow in this, wait, it doesn't work. Still too slow. Just now I run the program, there's nothing coming out. Huge challenge. Not because of my hardware problem. Yeah, implementation. Why is that? You see, I divide by 2, I reduce the number of steps by 2, right? But I do it twice. You see, I call the function twice. So if I call 8 times 4, it will become 4 times 4, another 4 times 4. Then 4 times 4, you do it twice again. 2 times 4, 4, 2 times 4. Then you do, for every step, you need to times with 2. You see? So isn't it the same thing? You need to, you reduce a step by 2, then you do it twice. So the efficiency or the time complexity, to be formal, is still the same. That's why, you get it right. You divide by 2, then you times 2 again. So what's the difference? The thing I want is that I only do it once. Why? Because I already know the answer. Why I need to do it twice? So the scenario I want to see is this one. You see, I compute once, and then I save the result. not only I can save the result, I can also save the time. Yeah, that's very right. From Jamie, very good answer. You can save it. How do we save it? You know that when you want to store a value inside programming, what you need to do is I use a variable. Somehow just by doing this, see, half equal to half plus half. I'm only calling this function one time. I store it and then I just access the value without needing to calculate it. So this time, hopefully, I run it. Right, we got the result. Can change to 20 to make it more impactful. See, so you see, implementation details are very important. You might seem that isn't it the same thing? From the perspective of mathematics, it is the same. But in programming, it's different because it takes time to calculate. See, so that's why I say Jamie give a very good answer just now. Then if you submit this course, finally, we will get accepted. For the question, maybe you can type in the chat instead of raising the hand. Thanks. And it only takes 77 milliseconds. So just now you see that even after 1 second, I cannot get a result, right? But this time, with optimization, we get a even less than 10 of a second. See? So if you can complete this challenge, then very good. You've got a very strong understanding on the recursion. Because I say you don't want to use for loop, right? But you can even complete all the challenges. Do you remember that I say that, you cannot use the divide symbol? You can do it using the bitwise tricks. So this is another challenges for those that is more experienced in CP. So in CP, right, we have something called the bitwise operations, which basically, numbers are stored as bits in a computer. So by you can doing the left shift, right shift to manipulate the numbers. So left shift is basically adding a 0 after the number. Right? 12, if I add a 0, what will it become? 120, right? It's the same effect as multiply by 10. So in the binary representation, it's the same thing. I left shift by 1, is add a 0 at the end, is multiplying by 2. It's just we are going from base 10, that we use in the daily life, into base 2. Same thing for division. Just now it's multiply, right? If I go to the left, so if I go right, it will divide by 2. So for example, 20, if I remove the 0 after it, what will it become? 2. And 20 divide 10 is 2. This is not coincidence. This is cononess. You can prove it somehow. And then for this one, even the modulus, you see the part where you want to check whether the number is even or odd. Before this, I use the modulus. But we can actually turn it into the bitwise operation also using the N1. It's like checking the least significant bit. I mean the final bit, whether it's 1 or 0. If it's 1, that means that it's an odd number. So these are just tricks. If you do this, then you complete all the challenges, 100 marks. Right? But there is an alternative. So just now what we write is the recursion, right? We calculate the solution and we want to bring it back. Before I go to feature those successful solutions, because they didn't write this variant, so at the end I need to write this code myself to show you, is that there is another way to write recursion and it's even more efficient this way, is that you only need to go down, we don't need to go up. Okay, let me explain what I mean. So as you can see, there is an invariant in the function. X times y plus z is a constant. The proof is as the mathematical formula F's there, but I don't want to go that deep into mathematics. Instead, let's look at the examples at the right. So you can see 10 times 4 is same as 10 times 4 plus 0, right? So according to my formula, I can divide 2 for the first number and times 2 at the right number. Since I divide and times, it should be the same, right? So you can see 5 times 8 is still equal to 40. And I do it another step. 4 times 8 plus 8. Because it's odd number, right? So I cannot divide by 2, so I need to move the 8 to the right side. You see the same thing. 4 times 8 plus 8. Eventually we are doing 5 times 8. So this time 4 is an even number. I can do it another time. Divide by 2, we get 2. 8 times 2, we get 16. You can still see 2 times 16 plus 8 is the same. So this invariant, right, is something we would like to value in our CP, is that if during multiple iteration of the program, something stays the same, right? This is usually the key for you to solve the problem. As you can see, 1 times 32 plus 8. Then we reduce it to 0 times 32 plus 40. Since we know that 0 times anything is 0, so we can ignore the first two numbers and magically we get the answer 40, which is the result of 10 times 4. And the program is very simple. Guess what? See? I'm calling this multiply for the two number, then I call this new function with z equal to 0 because adding nothing, all right? And then this is the thing I said just now. You see I run the code, still can run, although it doesn't change anything because it's the same number, but I can run it again. See, the number will come out. So this is even better because you don't need to, you see, right? At the end, the answer is there. You don't need to, go up and then, reuse the result to calculate a new number. So with languages with, tail call optimization, you can learn it afterward. It's out of the scope today. So this will actually improve the efficiency and the performance of your recursion program. And you can, with this approach, you can even turn it into an iterative program easily. Because, it's just, if you treat these three numbers as variables instead of function parameters, it will achieve the same effect. Yeah, all right. So it's the time, as I promised, those who solve the challenge will get the, featuring in my workshop. Although not to hundreds, as my promise. How many people are here today? See, this one actually I'm quite impressed, because I say you cannot use loop. Numbers in the program is because there is a hard limit on the number, right? Less than 10 to the power of 9. So there is a maximum number of bits to represent that number. It's basically is that I say do something for 4 times without using for loop. So what will you do? You just copy paste the same thing for 4 times. So you see, this one is quite unexpected. Think out of the box. This one I like a lot. And it pass the solution, pass the question. So he's actually checking through every bit and it's like it changes it into the binary representation and you check that whether the last bit is 1, then you add that number shifting by the same number, because as what I said just now, shifting is basically multiplication. So very clever trick here. This one also quite similar to what I did just now. This one is times 2 divided by 2. It's the same thing just now, but what is the optimization here? You see, there is only one recursive call here. Like what I shown just now, I have 2. When it's odd number and when it's even number. Why he only need to do it once? Because he checks that whether the number is an odd number. If it is, it add the 8. Then when you divide b by 2, because it must be a even number. It's like you ignore the last bit. Like you already consider the factor that is odd here, then b divided by 2, because it's basically floor division, right? It will ignore the final bit. So it is essentially same as b minus 1 divided by 2. So b minus 1 is a even number because b is an odd number. You minus 1, you get even number. Yeah. So good. You can even use this trick to improve the solution I shown just now. This one is also quite amazing. This one is using the for loop. So he didn't get all the bonus mark, but this one is also quite interesting. This one, like the first one I showed just now, is using the, checking every bit and times using the left shift operator. This one is even more powerful. He considered it in decimal representation, which base 10 we use in our daily life. So he also checked through every digit, but that digit is in a decimal representation, and he checks that and then adds the same number of 0, then it adds it the number of times. So same thing but in decimal representation. Okay, this one also very cool. Yeah, similar to the one I showed before, right? This one I also asked ChatGPT to produce the solution. Yeah, so I also invite the special guest here. This one very similar, very similar. So, but correlation doesn't mean causation. Maybe it's just by coincidence, right? So this one is the more powerful option here. It's the same thing. That's why I shown just now. You see, 2 times 2, x plus x is times 2, and you divide by 2. It's the same thing I showed just now. You times 2 on one side, divide 2 on another side. And if it's odd number, you need to plus x. Because like what I showed just now, otherwise you don't need to do anything. This is also the code, last 2 days I prompt GPT and it gives out a similar code also. But somehow today I cannot prompt it, so I didn't show lah. Okay, good. Okay, so is this a toy example just to show you what is recursion? No, because in normal code, like but in Python, right, you want to do multiplication using the times symbol. But what about more exponentiation? Like 2 power 5. We don't talk about Python lah. Python there is the 2 multiplication symbol to represent the exponentiation. But if I run this code, think how many maybe 10 to the power 8, power by 10 to the power of 8, divided by 10 to the power of 9 plus 9. If I run this, I don't dare to run this during the workshop because it will cause my hardware to lag. But if you can try this at your home, it's a very safe thing. Just that your computer may be lag for some seconds and it won't calculate the result because it will take so many time. But how to optimize this is that once you realize that similar to multiplication is just repeated addition, exponentiation is also just repeated multiplication. So just on the program, right? Just now it's plus, I just need to change it to times and add the modulus operator because in modular arithmetic, you can do the modulus into the multiplication and it still came out with the same result. You can research this afterwards. But just by looking at the code, you can see that it's quite similar, right? If something is equal to 0, return a finite answer. If it is even, you do the same thing, divide by 2, then you return the something. Just the operator is changing from plus to times, and I add the modulus. Can you see the difference? Yeah, this known as a reuse the experience. You know how to do repeated addition? They also need to, then you also know how to do repeated multiplication. And this algorithm here is very crucial for your CP because sometimes you see that they want you to return modular something. You need to use this code, not just doing the multiplication until it becomes a very large number. Then you only do the modulus. Then that will be very slow. So if you are using C++, then you need to use this code to perform a exponentiation efficiently. But if you are using Python, right? You just need to call the function POW and then pass the modulus at the end. In C++ and Java, I know there is a power function, but do you realize that it will output decimal numbers instead of integers? So this is the difference. But in Java, somehow if you turn it into a big integer, there is also a built-in function, but it's not so simple as Python, right? It doesn't, it's not me. I want to recommend people using Python, like just a statement, okay? Okay, so here, hopefully you have a very good understanding using recursion. So if I ask, if I want to print my name for 6 times using recursion, so how will you formulate the recursion relation? If you want, you can type in the chat, or you can, just imagine in your mind. I want to print my name for 6 times. So I can print it once, and then do it 5 times. Very simple only, see? Here's the code. Yeah, let me remove all this. Okay, if you want, you can type in the chat. Let's see who types faster. For example, print name. So there's a number of times I need to print my name. So what I need to do, print my name. Then I need to do it for times minus 1. Because I already do it once, so I need to minus 1 to the total number of times I need to do. I just call the function. For example, 6 times. Is it the end? If you think this is the end, that means that you didn't capture the explanation just now. We are lacking one thing, which is the base case. What is the base case here? Anything lah. For example, here, if times equal to 0, that means I don't need to do anything like I print my name for 0 time. Let's see whether this works. See, 6, right? Let's change this to 10. You print 10 times. You see, even without using for loop, ordinary programming, they use for loop for integer I equal 0, I less than 10, I plus plus. Somehow without using for loop, we can achieve the similar style. Similar behavior. So this is a very important knowledge in functional programming. If you know this FP, You see, we go from CP, DP, skip EP to FP. You can learn it afterwards. It's a programming paradigm. And I see Jamie submit his solution. Very good. So this is that he is actively learning. Yeah. Right. This is the solution if you didn't get it just now. Right. There are more examples. So you know that trees, they are a recursive structure. Why? Because you see the root of this tree, right? I know that tree in the programming world is not the same as the tree as the real world. In the real world, the leaf is on top and the root is at the bottom. In programming, it's inverted. The root is on the top and the leaf is at the bottom. Not sure whether the computer scientist has gone to the outside world before, but this is the convention lah. So the root here is 3, and it is pointing. You see, there are 2 fingers here. One is pointing to the left, another is to the right. The left here is pointing to the root of another tree. Do you realize that the root of a tree is pointing to another root, a root of another tree? See, tree point to another tree. This is also a recursive until you have nothing to point. I define tree using tree. So since so many tree, I also want to calculate the occurrence of tree in a tree. So when you are writing recursive code, right, I see most of the people, they want to go through the step by step just now. But if you remember the rule of thumb, I say just now, just need to consider 2 things: the base case and how you want to reuse the sub-problem result to calculate the problem. So here, let's show a very simple example. So if somehow, since the left side is also a tree, right? So if I pass this root dot left, which is the root of the left subtree, to this count tree function, I should get a result. We don't need to care how it gets the result. We need to imagine magically it gets the result. So here we have only 1 tree here. On the right side, we do the same. You can see there are 3 trees downwards. Then we need to calculate whether the node is also a tree. Tree, very hard to pronounce. So just by knowing how many trees at the left subtree, how many trees at the right subtree, and know, since you are the root, right, you should know what is the value you have. Then you add these 3 numbers, then you know the total number of tree inside a tree. I'm starting to regret why I need to put 3 as the example. But you should get the example here is you see 1 plus 1 plus 3. Very magical, right? It's like I'm not doing depth first search to calculate how many, to know the order, how I need to go through each of the node. I just magically assume that by using this function, passing the root, I will get the answer. And it really gives answer. And because eventually, right, you will go to the leaf at the downwards and the root will become nothing. So that's why the base case is if root is nothing, obviously there are no values, so there is 0 occurrence of tree. See, very elegant. Let's have a meme problem, which is about reverse linked lists. Okay, we save that for the Q&A. Yeah, we got a reverse linked list. There are many memes about I do reverse the linked list in my interview, but in the end, I just need to center the diff. But this one, if you use the logic of recursion, then you can solve it easily too. Let's show the example. Here, like what I said just now, magically assume. So this is the original list on above, 1748. I want to turn it into 8471. The head will become the last item, reverse the list. So how should we approach this problem recursively? Assuming by magic. This is the leak code formatting. Assuming by magic. Because this reverse list, given the head, right, it somehow should reverse the list for me. So if I pass the next node, because the linked list, if I cover up the example just now, right? If you cover the 1, 7 point to 4 point to 8, do you realize that it's the same structure? A node pointing to another node. That's why if you define the list, if you haven't defined a list node to construct a linked list, you will notice that you will refer yourself inside the definition. So here is also the same. So since the head.next, which is the next node, is also a list node, right? I can pass it to the same function to reverse the list. We don't need to care how it reverse the list for now. We just assume that it will do so magically. So if I run this, the new head will become the 8. You can see the last 3 nodes are reversed, right? You see the hand is pointing another way. So what we need to do now is we just need to fix the current step, the head pointing to right side. Okay. So now if I want to change this to point to the left side, of course, I need to call next.next, which is his finger to point to the head. Then head is still pointing to the next, right? Then I need to run this head.next equal to none, pointing to nothing. Then, what is the final thing we need to do is, we need to return the new head. Why? Because we need to return the new head as the result. This is the start of the list. And is it done? Not yet, because we need to include the base case. What is the base case? When there is 0 node or 1 node, do we need to reverse it? It's like there is only a single node. If you reverse it, it's still the same. So that's why you just return the head. By just doing this 1, 2, 3, 4, 5, 6, 7 lines, right? You submit it, you already can pass this leak code problem. See, recursive thinking is different from the iterative thinking. So to come to this workshop today, right? You open another realm of the programming compared to your other peers. See, and even beats 100% in the runtime because it's simple problem. Okay, for bonus exercise, for those from UM, right? There is a very horror level final exam in the data structure where you need to write a program to convert a binary search tree into a circular doubly linked list. This one I make it simpler, singly linked list. So this one is a challenge for those interested readers, how you can turn the tree into a list. It's quite hard, but I can show you a hint. See, if somehow you can turn the left into a list, turn the right tree into another list, then what you need to do is just combine the list. If they come to my workshop earlier, okay, so this is the first part of the workshop. We discuss the first problem. Now we discuss the second problem. You might be curious, well, we haven't talked about DP until now. But don't worry, we will be. Okay. So this one, we got to prepare a second problem. The second problem is very real world. Based on my past experience, back in my days, I won the PLN, not the Programming League National, the parallel line night. We got a hamper. Then I want to share with my girlfriend. She said that she didn't care what the items she want. So I just divide randomly. Then in the end, when she get the items, he take out the calculator and then calculate the total price of each item. Then she realized that she get less than me. And that's why we got break out at the end. If you believe this story is true, then sorry, it's just a set up story. But because I don't have a girlfriend to start with. But today we got a problem to start with. That's the good news. So you need to make sure your partner didn't get the items with a total price less than yours. How to do so? You come to this workshop, that's correct, because we need to use dynamic programming to solve this problem. So this is to make sure you have a more sustainable relationship. We got a real world example also. So what is the problem is actually you want to make sure that your girlfriend will always get higher or equal to your items. So in other words, basically the items you'll get, the maximum total price is at most half of the total price of all items. For example, if the total price is 5, if I take higher than the half is 2 by 5, right? I get 3. Then what is the maximum my partner will get? Only 2, right? See? So if I exceed the half, she won't exceed the half. She will always be less than half. Then how can it? So my items price will always be higher than her. That's why it cause a breakout lah. But this is a very good example today. You see. So in this sample input output, we can see that the total price of all items is 52 and the half is 26. So no matter how I take the items, I need to make sure the total price is not higher than 26. For example, if I take the first value and the last value, 30, how many left for my partner? Only 22. Impossible to be higher than the half, right? This problem is not that relatable. Come on, okay? Don't worry, maybe you do CP, then you find more relatable. So how should we approach this problem? If you didn't come to this workshop, maybe you only know about the greedy strategy. So see, maybe we can start with the lowest prices. Like we start from the smallest to the highest. We start with 6, 7, 8. We want to fit in the 9, but we cannot, right? Because it will exceed the half. Because right now we already have 21. If I plus another 9, it will be 30. So we already exceed the half. But the optimal answer here is 24, and we only have 21 so far. How is this correct? Right? So by going from small to big, there is an issue. What about going from high to small? Maybe we got a better better outcome, right? There is. If I directly use the highest value here, 22, I stuff it in. But then you realize I cannot stuff in any number because there, only 4 space left. How can I stuff in even the lowest one, 6? Then the final answer here is 22. I know it's better than 21, but still not the optimal outcome, which is 24. How should we solve this? DP, C. In dynamic programming, we do the same thing, one step at a time. So let's consider the first item first, which is 8. What if I take the first item? Okay, remember this scenario. We need to select from a list of items where the capacity is still empty. So the capacity here is 26, the half, right? But if I take the first item, if I take it, it will fill the space. Here is the magic time. See, take, I remove the 8. So what's the problem now? The same problem, just with different parameters. You see the magic? See, see again. There is an 8. Okay, I hide it. So it is the same problem, just that we have one less item to select. Before this is starting from 8, 6, 9, right? I remove the 8. But then the capacity changed. Before this is 26. I remove that, I already stuffed it, 8 inside, right? So how many space left? 18. Okay. If you realize that it is the same problem just now, what is the same problem? This one, right? We got a list of items, we got a capacity with nothing failed. Same thing, different parameters. Okay, let's see how we can exploit this characteristic later. Magic time. If we somehow found the solution of this sub-problem, somehow we got the solution, then how can we use that solution? I bring the 8 back. We can use it to solve the original problem. See, now it's 24, right? What if I don't take the first item? Still the same thing. You see, the items I can take are fewer, now starting from 6. But the maximum total price, which is the capacity, is still the same, 26. Let's do a comparison. So if we assume that we somehow, don't know how we get the solution, then we can compare the two solutions. Since we can either include 8 or not, the outcome must be coming from these two, right? So the solution has to be the maximum of 24 and 22. So which one is larger? 24. And 24 is the answer to our original problem. Do you realize that? See. And what does this remind you? Somehow get the solution. I don't know how. Why somehow get the solution? What technique does this remind of you? The front part is not meaningless. Okay, I bring this one. You see, the maximum total price of items selecting from the array starting from I to the n, there is at most S. The I is the item I can choose from, the S is the capacity. If I take the ith item, then what does it change? The number that I can choose will reduce by 1. That's why I make the I go forward by 1. And the capacity also reduce. Why? Because I take the item, of course the space will be smaller, right? If I skip it, what is the thing that is changed? Because why we go from I to I plus 1? Because I'm going to skip the ith item. Of course, I need to exclude it from my array. But the capacity stays the same because I put nothing inside, so the space will stay the same. You see, I purposely put purple color, the color of FSKTM. But what is the technique that this remind you? Not about one lecture, but about the technique just now. What technique? Can you say in the chat? Recursion. So somehow, right, if I have a function dp, which stands for the maximum total price of item, the same thing just now, it's the same purple thing, I replace it with this dp function, not the dynamic programming. Just by coincidence, this function have the same name as the dynamic programming, dp. So you see, same thing. If you haven't realized, you see again, the purple thing, I change it to dp. The orange color thing is the same. Let's continue. So recursion, right? Of course I type it in recursion. Yeah. Recursion. I need to use C++. Because C++ is faster. But don't worry, even though you come from Python background, the dynamic programming is not always about a language. It's about a way of algorithm thinking. So don't worry, if like you want to do it in Python, it's the same. So here it's the same thing just now, but something seems to be missing. Okay, let's talk about not about the absence first, but about the thing that is present here. It's the same thing just now. If there is capacity for me to take the ith item, then I write the same function, pi plus d, pi plus 1. Basically the same thing just now. If you didn't realize, see the same thing. If I can take it, I will take it. Then skip. Then I return the maximum of the 2 items here. Which is, no, I just, recursive code, right? It's basically describing things only. We don't need to care about how it, come up with the value, because somehow it will be able to calculate it. But here it won't. Why? Because something is missing. Which is, you should know the answer, the base cases. If you put the recursion, right, without base case, it will run infinitely. That's very right, Jamie. You get the answer before me. So what is the base case here? You can see that from the point of the parameter of this function, I is increasing, but the second parameter is decreasing, right? You can see I add 1 to the first parameter and I minus pi on the right parameter. So 1 will increase, 1 will decrease, or even stay constant on the skipping part. So eventually I will be equal to n. When I is equal to n, then the array will be empty, no items to select from. So what is the answer? If I have no items to select from, what is the maximum price I can get? Of course, 0, because I take nothing more. Another thing is, when the s is equal to 0, you can imagine that there's no space for me to put my item. Then how many items I can take? What is the total price? Also 0, because I can't take anything. Very sad. Okay. If I put this base case, then I should get the answer already. But how should I get the answer? Remember that what we want to find initially is dp0 half. If you substitute it, the 0 and half, into the function description, which is the maximum total price of items selecting from 0 to n, the entire array, there is at most half, because I say that I don't want to exceed the half and hurt the feeling, right? So by running this, let's see whether we can get the answer. Somehow we can get the answer. Copy the input, paste it here. Okay, wait, why it goes to here? I copy the one with the base case. Then I run the program. Do you think it will come out the answer? Let's try. Run it. 24. Is it the same answer? Yes. See, we already solved the problem. Very simple, right? If you submit this, you get time limit exceeded. Because just 5 items, of course it's manageable. But in the test case, the hidden one, we have at most 600 items in a hamper. So what does this indicate? If we only have 5 items, basically you are trying all combinations. Either I take the item or I skip the item. So basically you are, multiplication rule, there are 5 items, so 2 times 2 times 2 for 5 times 2 power 5, we have only 32 combinations. But when it comes to 600 items, how many combinations we have? 4 times 10 to the power of 180. Even the universe age is not higher as this. Even similar, we can process one combination for 1 second. Even though you process it for the age of the universe, you won't come up with the result. Then how we can solve this problem? If from the start of the universe, the Big Bang until now, I won't calculate the result. Then I got a time limit of 3 seconds. How is it possible to get results in CP? So there is something very helpful in this problem. So there is one characteristic which we know it as overlapping subproblems. Very high class term, but let's see what does it indicate. Sometimes we will arrive at the same stage. Let's see. If I take the 18, skip the 14, skip the 16, take the 12. You can see that the total, I already fill the 30 over 36 of the entire capacity. For another one, I take 14 and 16, skipping the 18 and 12. You can see that it is the same thing. It's not about the left side. It's about the right side. We are selecting, so the problem will become the same thing. Select from the same set of items with the same capacity. It's the same thing just now, right? Like the multiplication thing. Just now, the multiplication thing, why is it expensive before I put a variable? Because you do it twice. This one is the same thing. I do it twice. I'm wasting my time. I already got the result, but I didn't save it. Then I cannot save my time. So it's the same slogan. But how should we save this? because it's not just one value, there are multiple value. When there are multiple value, an array or matrix is come to rescue here. So here, since the output is dependent on the two parameters, right, the I and S, so we just create a memo array. You can see the point I highlight in the code. So what is the difference? I check in the end, right, the final line. Before I return the result, I save it into the memo array so that the next time, you see the second line, right, I check if the memo is not equal to -1, that means that I calculated this result before and I just return the result without doing the computation after it. So that means that initially I need to set the entire array to be -1, which is the the top right image here. Mem set memo negative. This one is a trick in C++. You set everything to -1. But of course, you can do the for loop for I to first row to last row, first column to right column, -1. Same effect. Yeah. So the thing is, what should the dimensions of the memo array be? In CP, not the software engineering, in CP, we only need to care about the largest value because when you are doing the time limit, memory limit, we only care about the largest value. So what is the largest value for I? So I is from 0 to 600, the maximum number of items. So there are 601 values. Why not 600? Because you need to consider the 0 to. What about the maximum price? The half of the total price. So 600 items times 500, the maximum price, divided by 2, that's the answer. So this is the maximum size of our memo array. So that's why the numbers is not come out of randomly. And you pass this problem already. See, I can submit this, but time constraint. See, somehow, just by doing this, you can pass the code easily. Why? Just now, even the entire universe time has passed, we won't find the answer. But right now, just by 1.2 seconds, we find the answer. Why is that? Because we go from the high 10 to the 180 combinations down to 601 times this number. It will be a much smaller number from 180 to 7. As initially what write 180 digits. Now you only need to write 7 digits. You can feel the difference, right? Why? Because you notice that 601 and that big number, right? That is the maximum number of values in our memo array. And for each of it, we only do it once. See? So that's why, there are cache mechanism, similar thing. We save the result to avoid recomputation. And this one, we also limit down the possible combinations. I can take an analogy. For example, I throw the darts. If I ask you to predict what is the location the dart hit, there are infinite possible outcomes, right? Because infinite points on the how to say that thing, the target. But if I ask what is the possible score, you can guess it in a limited number of count the times. Why? Because it's either 1 to 20 only, right? There is a finite number of choice. This one is also known as the pigeonhole principle. Like there are infinite, not infinite, maybe there are 10 pigeons, but there are only 5 holes. So we want to feed the pigeons, there will be a hole there with more than 1 pigeons, because otherwise how to feed, right? So this one, same logic, same algorithm. That's why I say this DP is not about the specific programming language. It's about the way you think it. So that's why I introduced a recursion. Let's see again. So this is the 3 result. So imagine I use the illustration of 2, 1, 1, 2. And the base cases, of course, is when I equal to 4, no item, or S equal to 0. So you can notice that overlapping subproblems exist. So you can see we reach the same state through different branch, right? You see the 3, 0, 3, 0, 3, 2, 3, 2. So for the the purple color 3, 2, right? I don't need to go down. I only need to calculate it once. Do the DP40, DP42. Then when I reach another node, another DP32, do I need to do the same thing again? Of course, no lah. I can use the result I saved it before. So that's why this is a key to solve the problem. And this is actually dynamic programming. See, dynamic programming is a paradigm that breaks down the problem into simpler sub-problems and stores their resolutions to avoid redundant computations. This is what I promised previously. So optimal substructure. So for the dynamic programming, they need to have two characteristics. This is the first one, optimal structure, which is to get the optimal solution for the current problem. You can get the answer by constructing from the optimal solutions from the subproblems, which is you are using the same way to solve the subproblems. So what is the optimal substructure? Is basically something like this. For example, here I want to go to the UM and I need to pass through the MRT station. So if the shortest path, I go to UM, must pass through the MRT. Then if I know the shortest path from here to MRT and MRT to UM, I just combine the path. Then I know what is the shortest path to go to UM. See, combine the solution. That's why I say break down the problem, not the mental breakdown, right? And then another key, overlapping subproblems. Why? You need to make sure the problem has this characteristic that the same subproblems are solved for multiple times. Otherwise, why you save it if it only have exist for one time, right? You need to save it because you need to reuse it afterwards. And if you think that this is not challenging enough, because I prepared another version, the challenging version, that takes us 1 point. So currently we have 1.2 seconds as 345 MB to pass this problem. But in the challenging version, I give the time limit of 1 second and 32 MB only. See how to pass the challenge? Before we pass the challenge, let's have a break, because I got a lot of mental breakdown already if I don't do a break, right? So maybe during the break, you can have some Kit Kat, or maybe you can even predict what is the topic I'm going to mention afterwards. Or maybe you can just leave a quick feedback of what do you think about this workshop so far? Am I going too quick? Okay, so I pass it back to the PLN side. Let's have a break of 4 minutes until 9:15. Thank you, everyone. See you later.
Okay, everyone. So we will now take a 4-minute break. Feel free to stretch, grab some coffee, or just relax for a bit, and see you again later. Yeah. Sam.
Okay, thanks. Okay, second. Yeah, let's welcome back. Such a short break, maybe not enough to release the breakdown, but we can release another thing, the break. Still the break, but just change some letter. Let's go. So no one predicted the answer, but given a top-down approach, it's not surprise if we have the bottom up. Just antonyms. So what is the top-down? The top-down actually is quite reactive. Like if there is a recipe, for example, I want to make a layered cake, then in the top-down, right, I need to check whether the cake exists. If it doesn't exist, then I need to go to prepare the cake. If the cake doesn't exist, I need to go prepare the ingredients, the powder and the batter. I got the powder, then batter haven't prepared. I need to go, buy the ingredients. Of course, very slow like this. So what we want to have? In the normal recipe, right? If we have, one step-by-step instruction, 1, 2, 3, 4, 5, 6, 7, just follow the steps and don't need to care about whether I have this item before, right? So this is a more efficient approach. So in programming, it's also the same. Can we have a order by order without checking the items, checking whether it's -1, very slow like this. Okay, let's take a closer look. So if I print the memo array after I print it, after I calculate the result, you can see that there are some values they are not calculated. Why? Because like the logic just now, I only prepare the value when it is required. So if I show another diagram here, table versus tree, you can notice that it's the same thing. Before this is a tree, but the state, right, I store it in a memo array. So first one, I start with 0, 3, the first row and the last column. I go down to 1, 1 and 1, 3, 2, 0 to 2, 1. So you can see that I missed some of the boxes inside the table. So that's why in a diagram just now, there are some values that are not calculated because they are not required. You only do the things that you're required to do to get the results. But that is too slow. We need to somehow find an order to fill in the values, like the things I said just now, 1, 2, 3, 4, 5, 6. And there is a key. What's the key? We need to make sure that, let's check the numbering again. You can see that it's always the larger value that point to the smaller value. For example, 10 points to 8 to 9. What happens if a smaller value point to a larger value? It's something like, I haven't prepared the prerequisite, but I already need to do the product because you need to do the find. For example, this one layer cake, right? I put it as 1. The ingredients also haven't prepared how to make the cake, right? If I already prepare the cake, then you see the future steps. I need to prepare the ingredients. Also, what's the purpose, right? So that's why the key here is that you need to make sure the larger number point to the smaller number. So let's do this. We can start from the bottom row. 1, 2, 3, 4, 5, 6, 7, 8. Fill in all required values, which means the one that is pointed by the arrows. So at the end, we get the value, right? But we don't know which values are required, right? If we don't know this arrow, I remove the arrow. Do you know what values are required? No, right? So what should we do? What should we do? Any guess? Since we don't know how many values are required, then we just fill all the values. So why even bother to choose, right? We're going to take all of them. So you can see, before this, I only fill the numbers on the points where we have the arrows pointing to. But right now, you can just fill in everything. And you can see that it's always the larger number pointing to the smaller number. So basically just 2 for loops now, right? Starting from the last row to the first row, first column to the last column. And if you find this familiar, because it's essentially the same logic, but we are the one defining the computation order. Just now the recursive, right? We don't know how we execute the result. We assume it by magic, it comes out the result. But in the for loop, we need to define the order explicitly. Like I start from the last row, go to the second last row, third last row. But you can see the main logic is the same. If I equal n, s equals 0, the base case, the answer is 0. Integer take equals 0. You can see lines are similar. Just like I replace the DP with the memo, the array. So because we're calculating all value, if you print the memo array after you're running this program, you see that all values are filled, even though they are not required. So do you think if we fill the values that is not required, we speed up or speed down our solution? What do you think? Yeah. If I submit this program, from 1.2 seconds, we reduce it down to 0.28 seconds. There is a reason. Because the reason I will review it later. But before this, there is some test your understanding, which you can read the slides afterward now. So does the program still work after we stop the loops? Also the same thing, imagine in terms of the number filling order. You see, I start from the first column, second column, also down to bottom. We still maintain the fact that larger number point to the smaller number. So it will work, but at what cost? It becomes 0.56 seconds, even though they are the same thing. Why? Because at a low level, it's about the catch. Because the array, the matrix, right, is stored as a rows of rows. So if you bring out column, that's why it's slow, right? And in the recursion, not only that you need to, because they are backtracking, right? Suddenly you go from the last row, you go to the second row, so the cache will get not hitting it, will miss. So that's why it has a higher time duration to run. And also there is a overhead of the function code. So that's why it will be slower. This one also test your understanding. If I reverse the order, does it work? It also works. Why? Because still larger number pointing to smaller number. You see, only a slight difference, right? What about reversing the order within the outer for loop? If I reverse this, then the problem will come. Why? You see that, for example, the top right, 4 is pointing to 6 and 8. This is smaller numbers pointing to larger numbers. Like I want to calculate the value for 4, but I haven't prepared the 6 and 8 because I haven't calculated it yet. So how we can get the right answer? We will get the wrong answer on test 1, even fail the sample test case. So that's why you need to make sure. Before this, Recursion handle the order for you, but right now you need to handle it yourself. Says optimization is about space, not about time. It's not about time for us to submit the solution yet, because the bottom of DP still takes a large space. We want to reduce it down to below 32 MB. So let's take an even closer look. What optimization opportunities do you see from here? Do I really need such many space? Really? You see that? Let's see again. Hey, something transparent. What do you see? You see that? Every row, right? It only depends on the value in the next row. You notice that? You see, every arrow, right? It will point to downward, but only for one step, not the second step. What does it tell us? Is that we only need 2 rows. Since when you calculate for example, if I redo the process again, when I calculate the 3rd row, I only need the 4th row. So when I calculate the 2nd row, do I need the 4th row? I just throw it away lah. I use the 3rd row only because it's only dependent on that. Same thing, I go to the 1st row. I only need the 2nd row. Then for the 0th row, I only need the 1st row. So that's why I say that, just enough. We only need 2 rows. Why we need 601? But we only need 1 when we want to calculate the value. What's next? We have another variable, current, for the current row, and 1 minus current for the previous row. Why is that? It's because that there are 2 rows, right? So the index is 0 and 1. So if I use current equal to 0, 1 minus current will be 1. If current is 1, 1 minus 1 will be 0. You can see that it's always the opposite. So that's why I can see how I optimize the program. I set a variable current equal to 0. When it's I, right, that means it's the current row. I say to current. When it's I plus 1 is the previous row. I say to 1 minus current. Do you see that? Just by doing this, I can pass the solution already. You see, wow, very cool, very exciting. Before this, we are from infinity time down to 1.2 seconds. Right now, only not even 1 second, not even half of a second. The memory is also the same. Before this, 345 MB. Right now, not even 2 MB. Come on, we finally passed the limits. But is it the end? But before this, let's test your understanding. Can we optimize to use 2 columns instead of 2 rows? Let's see, seems possible. You see the first column only pointing to the the 0th column. But if you move your perspective, the second column require value from the 0th column. Then what to do? You already delete or overwrite the value. So that's why cannot, you can only do on row basis instead of columns. So here, our final goal, can we reduce this to use only one row? Is it possible? 2 rows just now, I think it's still too large for us. Let's reduce it to 1 row. Okay, let's assume that we already fill the bottom row. Since we are only using 1 row, right? It must include overwriting when we need to include a new value. Not like just now, because the previous value is not affected by the current row. So if I fill 5, you see, the 5, I replace 1 with 5. Because there are no arrows, but with 6, right? It's pointing to 2. That means that it requires 2 to calculate 6. But before we overwrite with 6, the 2 is still there. So of course we can do that. See this 7. We need, you see the arrow 1 and 3, right? We need both of them to construct 7. But you already overwrite the 1 with 5. So gone already lah. How to calculate? But it's not time to give up yet. Let's attack from another direction. Just now we are going 1, 2, 3, 4 from left to right. Right now we go from right to left. Are there any difference? Let's see. When we are calculating 5, we need 1 and 3, which is still there before I overwrite it. 6, 4 and 2, 7, pointing to 3, which is still there, and 8, the base case. 8, magically we can do that already. Why? If we notice from the DP relation, we see that we only need values from the current or left columns in the previous row. You see that the arrow always point to left, not the right, and always downwards. What does this tell us? Is that because we are overwriting from right to left, right? When you point the arrow to the left, it is still the old value. Because we start from right to left. The left value are still the old values. Just now we reverse the order. We point to left, right? But the value already got overwritten. That's why we get wrong results. So we can, using this idea, eliminate the first dimension. Before this, you can see there's 2D array. Right now, I cut the first dimension and I reverse the direction because 0 to half is impossible. We need to go from half to 0. And by doing this, right, we can cut down the cost even more to 0.14 seconds and 0.6 MB, about half, See, this is DP knowledge, optimization. So let's compare the top down and bottom up. From top down, you can see we start from the top and we go to downwards. That's why the name is top down. From the bottom up, we start from base cases and we're moving up, building from the bottom to the up the original problems. So for the top down, right, because we don't know the order, so maybe when we are doing the second row, the arrows still point to the downwards, and you need the value from the previous needle. So that's why it's more difficult to do the space optimization. But with the bottom up, we have the control of what values need to be counted before we do the processing. So that's why we can have the space optimization. Yeah. This is actually a classic DP. Like there is a bag, where there is a set of items with a value and a weight, and a knapsack with a maximum weight capacity. So we need to choose a subset of items such that the total weight does not exceed the capacity, but we also want the maximum value. Like you want to steal things from my house, then of course you need to take the valuable things, but you only bring a bag. Of course, you can only select limited number of items, but you want to make the highest profit, then you must use DP when you're stealing the items. You see, real world application. So this Minecraft example is the same thing. You see, we have the value and the weight. The answer here is 4 plus 4 plus 2. You see, we achieve a maximum profit here, $18 by fitting entire knapsack. Why we cannot take, all the items? Because there is a hard capacity. So the solution code, if you think it looks familiar, it's because that the problem we just now is actually a special case of 0, 1 knapsack where value is equal to weight. You see that? At the left side, we have weight and value. The value is the one we add to the memo. I mean the result if we take the item. And we need to compare the weight, which is the space it occupies in the knapsack. But at the right side, we replace everything with P because value is equal to weight. And another knapsack is an unbounded knapsack where you have unlimited quantities of each item. So this produces a different answer. You see, we need to take 3 irons instead of 2 because unlimited, of course, need to make use of the advantage. Also, we have more DPs. For example, DP on trees. We need to find the maximum sum of knot values such that no 2 selected nodes are adjacent. Initially, I want to ask what is the maximum value you can get. You can select any set of values. I need to make sure that there is no edge connecting between them. Maybe you have an answer in your mind already. I can reveal the answer is 64. Let's see whether you reach this maximum number. Because this one is like DP like I can only take or skip. If I take this, I cannot take the children, something like this. So you can feel the DP sense in it. Another thing is maybe the digit DP. Count the integers from this range where no adjacent digits are equal. If you look through each number, it will be simply too slow. So that's why you need to use DP. But because this is the introduction to DP, right? We don't make it too difficult here. You need to learn yourself. And more DP lah. This one if you master of this, I promise PLN champion with you. Okay. For example, the matrix chain multiplication is a classic example. You see, we want to times the three matrices, right? You know, matrices, you need to make sure that a lot of items, right? You need to do the multiplication one by one, then you add it out. So this one, A times B times C. If you just A times B times with C, so many multiplication, you see such a large box, times with the vector. But if you do it smartly, you see B times C, you will reduce it to a single number, which is a scalar number lah. Then you type with a vector, very easy, right? So this is also another application of DP, known as the range DP, where you can reduce the number of multiplication you need to calculate the multiplication between multiple matrices. You can challenge yourself whether you can implement this. Yeah, so it's not just about CP. This one is a past year problem, the sector third problem. But the problem is you don't have enough time. Don't worry. This one is a problem where this given the poison damage and the immunity time, how should the crazy Dave consume all the plants while taking minimum damage? Note that the Dave can only eat exactly 1 plant per second. So for example here, I give an example. I can consume the second plant. I take the 10 damage. You see the second row, right? 10, 1. I take 10 damage, not me, Dave, take 10 damage and gain 1 second of immunity. So during this immunity, he can consume the first plant. You see, initially he take 100 damage, but because due to the immunity, right, he takes no damage. So this is the key to reduce the poison damage. So because only 1 second, then pass already, we can need to take another plant and take the damage. But this time we get 3 seconds of immunity. So see, then we can eat all the plants without taking any damage. So the total damage taken is 35. Determining the consumption order seems to be the part of the solution, right? But I need to know, I need to eat this first to get immunity. But in CP, right, a very important key is that we need to reduce the complexity. If we want to find the order, very difficult. But if we suppose that if he chooses to eat the plant while he's immune, the immunity time will be -1 instead of the value I shown on the right side. If I eat during immune, the time will be -1. Then the problem reduced to finding a set of items with a total immunity time greater or equal to 0. Why? Because there will always be enough immunity time to eat those chosen plants. Otherwise, the immunity time, if it's -0, right, that means that you eat more items than the immunity period. So if you can make sure this characteristic, total immunity time greater or equal to 0, any order is acceptable as long as only those plants are eaten. So dynamic programming, define a DP function, like this one. The range IN and the time is the number of seconds left. And this one is also same, take or skip. If I take it, then if I take it, that means that I take the damage. So the damage, I will take it DI plus but by doing this, my time also increased, the immunity time, the poison immunity. But if I choose to eat the plant during the immune time, then you see the time -1 because I use 1 second of my immunity. It's the same thing lah. I want to find DP00, but base case are missing. Yeah, base case are missing. So you see the base case, you see that the first value I+1, right? I keeps going up. Of course, you need to hit the bound. So when I equals to n, there is no plants, so 0 damage is taken. So we need to filter out the invalid cases where the time is negative. So how do we do so? Because we want to find a minimum, right? If I set a very large number, like 1 times 10 to the power of 18, so we can make sure that this number will never be chosen, right? Because we want to take a minimum. This number is so large, how can we choose it? So this is something we can use to filter out the invalid cases. Also, we have overlapping subproblems. Before you're so eager to apply DP, make sure there is a overlapping subproblems. For example, this one. I take the first and third plant while immune, second and fourth while not, we will achieve the same result, that we only have 2 plants to eat and 0 immunity time left. So same thing lah for the time. Yeah, this one. This one is, if you apply the recursion relation just now, you can read it. But this one, due to time constraint lah. This year workshop is not like last year. Last year workshop I have 2 hours. This time we have 15 minutes left. But don't worry, that one is the the hard path to get the solution. I can show you the simple path. You see, do you realize that this problem is the variant of the knapsack problem we discussed just now? Consider that the value is the damage, the weight is the immunity time, and the knapsack capacity is the number of plants. So we should find the minimum total value with a total weight not less than the capacity. I know this is confusing, but don't worry, example is coming. So here, it's like, if I choose to take the damage, right, then how many plants I can eat? That plant that I eat to get the immunity and the immunity time it provides. So it's the same knapsack problem that we need to feel the knapsack is possible to exceed it, but we need to make sure the minimum possible value. So I should answer here, 10 plus 25. We can fill the knapsack, and the 10 plus 25 is the output with 1. See, it's actually a knapsack problem. I didn't realize this last year. I only realized this yesterday. Okay, so since this is the knapsack problem, what can we do? Reuse the solution from we shown just now. See, just now is the weight, right? Right now, what is the weight? What is the value? Just replace it. But this time, it's about the minimum damage, right? So you can see before this, the knapsack, we want the maximum, now we want to find the minimum. But overall, feel similar, lah, right? End already. Sorry. You see the tick, right? What are we counting is actually the minimum damage I can take to exceed the capacity. So instead of take before this is 0, right? Because I can't take anything. But right now, if I take this item, of course, I may reach or exceed the capacity, right? If I didn't reach it, but even if I didn't reach the capacity, right? But I still hit the number of plants I can eat. That means that we can allow it to be greater or equal than, greater than or equal to. So that's why the 0 will become damage at the end. And if I see that, oh, there is some space left, right? Ti plus 1 less than or equal to S, which means that there are some remaining space, then I need to cater to the remaining space by using the memo array, the value we saw just now. Not just now, maybe in the previous iteration. All right, I'm gonna have some fun. I know, very pressure going through so fast. There are many DP problems, and DP problems, right, are mostly the decider problem. This is very great luck to come to the workshop today. Because if you solve a DP problem, you have a very high chance to win. Like this time, this is an influential DP problem in my context experience during 2023 connection. So this one, long question, and then the small constraint, sometimes is the hint for you to identify that this is a DP problem. So I came up with a DP problem. This one, DP with 5 dimension. But that time I didn't come up with the space optimized solution. I only come up with the top-down one. That time I still noob, cannot process it. But somehow, right, because I solved this DP problem partially, you see the score I get 252. So I count at the top due to this decider problem, DP problem. So that's why, that time is very stressed. I go big or go home. If I didn't solve this, then bye-bye already. But somehow I solved this. Pure luck, not pure luck, partial score. All right. And 2024, this time I also, level up a bit because 1 year passed already. This time I did come up with the space optimized bottom-up solution. So this is also another DP problem, but that time, right, because I saw the time limit and memory limit is, quite tight. So I spent some time to reduce the top down to the bottom out. And you know that it takes some time, right? Then when I submit 62 milliseconds at 500 KB, very good, right? Actually, I'm the only one who solved the problem during the PLN 2024. Then yesterday I tried, even the top down can pass. So this over optimized. See, that's why you need to have more experience to know what is the limit of the problem. 1 hour wasted. Okay, 2024, this one key. Why is key? Because in a prelim round, right, there is no DP problem. So I make a bet that if like last year, the DP problem is still at the end, and if I solve this, I can get the maximum score. then confirm on top already. So I bang heavily on the DP problem. I spent some time to read the DP problem. But it turns out it's not the hardest problem anymore. It's the second hardest. That's why you can see, right? The second row, which means the first runner out, you see there is a green 200, right? Is that I'm the only one who solved the DP problem completely. See, in 50 minutes, 200 score. I used all my brain cells on that. But it turns out that it's not enough to clinch the top place. This one is bad lah. Go big or go home. This one I go home lah, right? Because in the prelim round, the last problem is combinatorics problem. Then I predict that since the combinatorics problem already came out, that the final also came out the same problem. It did came out the same combinatorics problem. So make sure you need to have a comprehensive skill set, not like me focus on the DP too much. I don't need to give a workshop today. But giving this workshop, right, it's not just about suffering. It's also about a summary of my experience today. So here I want to share the 3R. It's not just that I recycle the slides last year, it's also that we can apply 3Rs, not the sensitive one. I mean the recycle one in the dynamic programming. See, reduce the complex problems into smaller sub-problems that converge to base cases. Then you can reuse the result to solve the original problem. Also, you can reuse the results of the previously solved sub-problems to avoid recomputations. And then we can recycle. Just now we do a recycle, right? We know that this is a knapsack problem. Then we can recycle this well-known solution to solve similar problems. By using this 3R, we can contribute to the sustainable development goal, and then we can make CP great again. Yes, this is my last words because I don't right now I already graduate. I cannot participate in the CP anymore. I mean the university level CP lah. They are international level CP, but too high level I cannot join. Not cannot join. Can join, but I cannot get any prize. That's not the key today. The key today is I must appreciate all of you for joining this workshop today. I know I'm rushing towards the end, but I know the attendees not quite high as the last year, maybe due to the Saturday or maybe publicity. I don't know, but I know that they make a great effort, especially my director, Kim. Last year, I received a thank you note from my director. This year, I am the one who gives a thank you note. So thank you very much for inviting the people. I know a lot of efforts put in the marketing, to attract the people. But somehow, people attract. There's interested in the dynamic programming is not quite high enough lah. So these are all the the quality participants that joined the workshop today. So I really appreciate for you for coming. So by coming to this workshop, I hope you can learn something new, learn new perspective, even though you are not joining the PLN contest, even though I recommend you to join. But if you don't join this knowledge, right, the recursion or the dynamic programming is about the optimization. I know this workshop is not like fancy titles like use the image gen or generative AI, what NLP, very fancy, very high class. I know it's high class. I know if you compare like this one is you learn how to use generative AI to create image. Another one, introduction to dynamic programming, is the obvious choice is here. But somehow you still come to here today, very touched. So this is the key So that's why you want to reach the top, you need to make sure that your root and your foundation is also strong enough. I mean the tree for example, you want the tree to grow high, right? Then the root must also go down to the bottom to capture higher. Not the inverted tree in the programming world. I mean the real world tree where the leaf is on top, right? So by doing that, you have a stronger foundation in terms of mathematical knowledge or the optimization. It also helps you when you want to deep dive into the AI or any of those fancy things right? You cannot just use it. It will be better if you are equipped with the knowledge to understand it. So today, not only the problems are broken down, you also face a mental breakdown. Not mental breakdown, I mean, you have made a breakthrough in your life today for coming to this workshop. Thank you very much. Let's give back to the PLN side. And if you want to connect with me, here are the links. Thank you very much.
Thank you so much, Mr. Sam Wei Hong, for the interesting and fantastic sharing session. Your explanation on the topic truly gave us a fresh perspective, and I'm sure that it has shown us of what dynamic programming is. I'm sure that all participants could agree with that. So let us give Mr. Sam a virtual round of applause, shall we?
Yeah.
All right. Okay, that's nice. After today's talk by Mr. Sam Wei Hong, I'm sure that the participant might have question to ask our speaker. So we have attached the Q&A link in the chat box and the QR code is shown on the screen. So feel free to scan and ask any question regarding the workshop today, and it will be answered in this Q&A session. Okay, so right now we have the first question. Is it super hard DP question coming out in final round of open category?
You know, like, just now the problem, right? It seemed easy. It's like, yeah, I just, do the recurrence relation, then, plus minus, turn it into bottom out, and I solve the problem, right? Seems so easy. But in the actual context, right, it, not many people actually solve that problem. The problem C just now. I mean, only one person solved that during the contest. You see, I make it simple, but it's actually not simple. It's so, even simple DP problems is already a challenge for the new participants. So why there is a super hard, even easy DP question is already enough to crush me. So I don't know because I don't know because how can I know PLN questions? So maybe yes, maybe no, but you should put more effort in learning DP. That's the answer.
Okay, so the second question, where can we get this slide? Okay, actually these slides for the workshop 2 will be posting in our Discord later. So are we able to view past question to see how hard the computer will be?
Yeah.
That's a tricky question. Let me get back to you later. Okay, how do I know I'm ready to join the competition? I think this one Mr. Sam can answer.
Yeah. So for the competition, right? Do you join my workshop contest? I don't know whether yes or no. Then you can still try it afterwards. To make sure you are ready to join the competition. The contest platform we use in PLN is the Code Forces. But the Code Forces is not only used to host PLN. It's actually a global platform. So there are also online contests in the platform. So you can join the contest to know your the real skills. You cannot just claim that use the GPT, I can solve the problem. That means I can solve the problem during the contest. If you think like this, then you will face a very big drawback during the actual contest. So you need to have a real contest because competitive programming, without the contest, how can it be competitive, right? So you need to join real world contest. Real world contest, then you know what is your disadvantage, what is your weakness. Then you need to refer to world-class resources to solve these drawbacks. Then you can achieve world-class performance during the actual contest. That practice makes perfect, quality practice. Okay. I also don't know how you are ready or not because I don't even know who you are, but you can make yourself more prepared.
Okay, so for the question just now, are we able to view past question to see how hard the competition will be? Actually, yes, and I think we will let you know guys later about it on our Discord. So are you giving surprise question in the final round? Okay, that's a
I,
surprise one.
Yeah, such a surprise question to me. I also don't know. I don't have surprise answer for you. Okay. I don't know because PLN contest control protocol, they have their own ideas. I also don't know. I'm just a workshop speaker. Okay.
Okay, I think we can move to the last question. Okay, 1 month left, and what should I focus on to prepare to get into final round? As most of my teammates are beginner only.
Are you I'm not sure who's your identity. Maybe you are the UM closed category or, okay, let me rephrase it. So if you are beginners like year one students in UM, that's very good. We have a backdoor, the closed category for you to join where there is no, the strong outsiders that is going to compete with your prizes. So by that one, right, you are actually in a comfort zone that you only need to compete with the internal participants. So your chance of getting the prizes will be higher compared to we need to versus the strong members outside. For example, those in the chat so active or something one. But if you are, the normal beginners that you are joining open category in PLN for the first time, then congratulations. Spend more time in a CP, practice. Last time during my first year, right, I also just realized about the CP when PLN, they announced the event. Before this, I don't even know CP, Then, wow, very nervous lah, The time I know the PLN, which is CP, is just 1 month away. Then I still, every day I do leak coding to improve my skill. I know leak code is not the standard CP platform because it gives the input to you directly without you need to read the input yourself from the standard input. But somehow that also prepares me well enough for the closed category contest. Then in next year I can already get a champion in the open category. Still, it will take time, but it means that how many effort you are going to put into the CP. I know CP is not so fancy lah compared to the AI hackathons. By just saying AI, a lot of sponsor come already. CP yeah, another story So this is also the same thing. You might be more excited at CP, AI, generative AI, new items is good. But if you want to be good in CP, you also need to spend the same amount of effort to be better because it's CP, right? It's not like the contest there with the presentation round where you can present with the judges how good our solution are, even in the back it's not that good as you presented. But in CP, right, it's different. It's the machine that will judge you, and the machine, right, don't have feeling one. If you produce a wrong answer, time limit exceeded, give you the verdict directly. So you need to make sure that your hard skills must be strong enough to crush that machine, right? So how to get the skills is through practice every day. Yes.
Okay, so you have any tips or routines to get better? Okay, we already answered that. Okay, how can I claim my ECET? So for the ECET purposes, so we will be validating everyone's responses in our Google form. Then we will submit everyone's ECET later. So okay, so let us move to the next last question because the time is running out. So what is your personal time threshold to abandon a question after getting stuck?
I don't. I'm also not sure. Maybe 0 to 1 week. I still remember that there is a problem. I haven't solved it last year. Yeah, but I haven't go read the answer yet. This one, maybe infinity lah. Sometimes I also forgot about the problem. Yeah, that's the answer.
Yeah, so that brings us to the end of our Q&A session. So thank you once again, Mr. Sam Wei Hong, for addressing our question with such clarity and making this year's PLN second workshop a success. So now we would like to invite everyone to take a group photo with all the participants. So please turn on your cameras and give us your big smile. Everyone, you may open your webcam right now. All right, everyone. In 1, 2, 3. Thank you. Okay, and once again, all right, everyone, in 1, 2, 3. Okay, all right, ladies and gentlemen, the PLN second workshop has come to an end. We would like to express our deepest gratitude to Mr. Sam Wei Hong and not to forget everyone who participated not only in this workshop, but also in the first workshop. Please fill in the feedback form by scanning this QR code displayed on your screen or clicking on the link sent in the chat box. Your feedback is highly appreciated. Please take note that you have to fill in this form to get the certificate of participation. This workshop recording will be uploaded on Percom's YouTube channel, and feel free to check it out if you have missed anything. Before we dismiss, it is still not too late to register for this PLN yet. Yep. If you haven't already, do scan the registration form QR code. on the screen, and remember to follow us on all our social media platforms to stay updated on Programming League National 2025. You can find us on Instagram at Programming League and join our committee on Discord through the official PLN channel. If you missed out on the workshop or would like to revisit the session, the live streaming recording is available on Percom's YouTube account. And I'm Jay Sharma, and it has been a pleasure to be your host. Have a great night, all the best, and goodbye.